you sit at a table looking down at a plate of food. Perhaps you are not even particularly hungry, or perhaps you leave a few bites behind, scraping them into the bin without a second thought. To you, food is an environmental constant, a landscape of endless choices glowing behind glass doors or waiting on supermarket shelves. But if we pull back the camera of time, even just a few generations, the floor beneath this modern luxury drops away. For 99% of human history, your ancestors lived on a knife edge of caloric precarity. They survived winters where the wind screamed through the cracks in the timber, and the pantry held nothing but dust and dried rind. You might believe you are entirely separate from their desperation, safe in your temperature-controlled room. But beneath your skin, at the very core of your cellular machinery, those ancient winters are still raging. The hunger your grandparents suffered did not die with them. It rewrote the code of who you are today. How can a famine you never experienced still dictate how your body stores fat, fights disease, and responds to stress? To find the answer, we must travel to an isolated, snow-locked parish in northern Sweden called Överkalix. Here, during the 19th century, the community was entirely at the mercy of the harvest. In years of bad crops, the people starved. In years of abundance, they gorged. In 2001, a Swedish preventative medicine specialist named Dr. Tuss, Lars-Olof Bygren, published a groundbreaking study in the journal Acta Biotheoretica. Bygren analyzed meticulous historical records of births, deaths, and grain prices, stretching back over a century. He discovered something that defied the classical rules of biology. If a grandfather experienced a sudden winter of overeating and abundance just before his puberty, his grandsons were 4 times more likely to die of diabetes. Conversely, if the grandfather had starved during that critical prepubertal period, his descendants lived significantly longer, healthier lives. It was as if the grandfather's body had taken a chemical snapshot of the environment and sent a warning message forward through time, bypassing the slow, grinding gears of Darwinian evolution. For decades, standard biology taught us that the genetic blueprint we inherit from our parents is set in stone, altered only by random mutations over thousands of years. But Bygren's work pointed to a shadowy second layer of inheritance. To understand how this works, we have to look at the epigenome, a complex system of chemical tags that sit on top of our DNA. If your DNA is a massive library of books, the epigenome is the system of sticky notes and bookmarks that determines which volumes are read and which are locked away. In 2008, a team of researchers led by epidemiologist Dr. Sophie Baes-Heemans published a landmark study in the Proceedings of the National Academy of Sciences. They investigated the survivors of the Dutch hunger winter, a brutal famine imposed by a Nazi blockade of the Western Netherlands in the freezing winter of 1944. Over 4 million people were rationed to as little as 500 calories a day, surviving on grass, paper, and tulip bulbs. Hegemans and his team examined the blood of individuals who were conceived during this terrible period of deprivation. Even 60 years later, these individuals carried distinct chemical markers on their DNA, specifically a reduction in methyl groups on a gene called IGF-2, which is crucial for human growth and development. The famine had chemically altered their genetic volume dials. The children of the hunger winter grew up to have higher rates of obesity, elevated cholesterol, and increased susceptibility to schizophrenia. Their bodies had been programmed in the womb for a world of scarcity, a world that never arrived. The discovery of these epigenetic bookmarks shattered the scientific consensus. It revealed that our life experiences can leave physical scars on our reproductive cells, echoing down the generations. But how does a physical experience like hunger or stress translate into a chemical tag on a strand of DNA inside a sperm or an egg? In 2014, neuroscientist Dr. Isabel Mansouri and her team at the University of Zurich published a crucial study in the journal Nature Neuroscience that cracked open this mystery. Working with mice, Mansouri subjected young males to unpredictable, traumatic stress. She found that this trauma altered the expression of specific molecules called microRNAs in the animal sperm. When these stressed males bred, their offspring exhibited the same depressive behaviors and metabolic abnormalities as their fathers, despite never experiencing the trauma themselves. The researchers even injected the altered microRNAs directly into healthy, unstressed fertilized eggs, and the resulting offspring still displayed the trauma symptoms. This was the smoking gun. The environment does not change the letters of your genetic text, but it changes the ink. When your grandfather starved, his body panicked. It realized that the world was a hostile, barren place. In response, his cellular machinery attached tiny chemical caps called methyl groups to specific genes while stripping them from others. This molecular editing was designed to prepare his future children and grandchildren for a life of hardship. It was an act of evolutionary love, a biological warning system sent across the decades. But when that warning meets the modern world of fast food and sedentary lifestyles, the message misfires, manifesting as chronic illness, anxiety, and metabolic dysfunction. Now, return to your modern kitchen. Look at the food in your hands. When you feel an inexplicable craving for sugar or fat, or when your body seems to stubbornly cling to every calorie you consume, you are not simply witnessing a personal failure of willpower. You are listening to the echoes of a cold winter long ago, when an ancestor you may have never known huddled near a hearth, wondering if the spring would ever arrive. Their survival strategy is now your physical reality. This realization carries a quiet, staggering weight. It means that we are not self-contained individuals starting our lives with a clean slate. We are walking archives, carrying the physical memories of our ancestors' struggles, their grief, and their hunger. The choices they made and the trials they endured are wired directly into the way our hearts beat and our brains process fear. But this story does not end with the past. It is actively unfolding in this very moment. The habits you cultivate today, the air you breathe, the stress you endure, and the food you put into your body are currently writing new chemical tags onto your own DNA. You are whispering secrets to descendants who will walk this earth a century from now. When they look back at this era